So good morning, everyone. So you're the lucky survivors of yesterday night. You made it. Um, just in time for a lot of code in the morning. So hi, my name is Martin, and welcome to my session on improving your .NET applications to make them smaller, faster, and better suited for the things you may deploy to, like cloud environments. I'm actually from Austria, although I work for a Nordic company, DevOps, which is based in Finland. But I always like to say we're a small Gallic village in Austria. And I want to do a few things with you today. I want to go through a couple of the things that matter to me, like why do I want to optimize certain things, but really I want to show you some fancy demos in .NET. Like I want to really show you how to get a web API to a couple of megabytes in size and easy to deploy. And I'm going to hopefully give you some practical recommendations. Even if you're maybe not already on the .NET 8 previews, I want to show you something that can speed up your application by like 10 to 20% today in .NET 7 with just one change. So what do I like to optimize, or what can we optimize? So I think the most of you will be familiar with optimizing throughput. That is like, how much work can you do per CPU amount? Like, what do you get for your money? Make things faster, make things consume less resources, and also memory usage. So we like to have small containers, maybe small memory footprint, or deploy a lot of things side by side. And for these, both throughput and memory really make a difference. But also in cloud workloads, startup is quite important. Like how much time, how much CPU do I need to get from 0 to handling the first actual user request? And also, when deploying things, it really matters how big the application is. So if I want to deploy something or start up an instance in Azure or any cloud, and it has to download a 300 megabyte container image, like that might be fast in the cloud, but maybe if I want to do it on premise somewhere in a factory, like in a remote area, that might not be the best idea. So these are the things to keep in mind. So what I'm usually faced with is do I throw more money at the cloud or at the developers? Like, do I pay for more CPU or do I pay for more application improvement? And these development improvements, they can be hard. So I see a lot of people just saying, okay, let's just buy the higher tier in Azure, we'll be fine. But some of these optimizations really matter, and some of them are easy, some of them are hard. So whenever I'm increasing my throughput, I'm actually lowering my cloud bill. So being able to do more per CPU, I can just maybe turn off a few servers, turn off a few Kubernetes nodes, especially for serverless applications. They may not spin up as many instances, so that might be just cheaper. And then again, if I use .NET, how much startup time do you need for cold starts? Like, does it slow down my users? Is it impactful from my user experience? Or do I hit unjetted paths? So I deploy my application, it runs, and then someone says to my application that returns data, and now make a PDF report out of that. And then it suddenly hits like graphics libraries, layout libraries, PDF libraries, and that might just take a bit. So I like to run things in Kubernetes. So as I mentioned, container size really matters, especially when deploying to on-premise environments and hybrid environments, things like deploying on the edge. That's really where these size considerations come in. But I also like to have test environments with lots of instances running side by side, or also maybe jobs that run with low CPU. So maybe I want to be able to run efficiently on maybe a quarter of a CPU core, like 250 milli-CPU, because that might be enough to make some database calls, do all the regular things. But then maybe can I do the actual JITting, the startup, with that amount of CPU? So if I have, for example, a cron job, because my platform comes with a scheduler, I might as well use it. Like, it's not the ideal solution for everything, but maybe if I want to do something twice an hour or twice a day, perfect way to do it. And then if I deploy something with maybe 100 milli-CPU, 200 milli-CPUs, I might be stuck with like 30 seconds of just startup time, which I have to pay for, I have to account for. Maybe there's some ways to improve that. And also CPU limits. Like in Kubernetes, you set basically a request that's used for scheduling the things on where you have CPU left. Those are limits, and it really depends on which blog post you read to get a different recommendation on what to do. So there's no real good answer, but yeah, I can set no limits. Like my startup time is going to be fine. I'm going to run good until something happens and I just DOS the node. Like if you use on-premise things and you maybe did not read the full Kubernetes manual, which says, hey, these are our defaults, and by the way, they are bad because, then you might actually crash a whole cluster. So that can go wrong. If you set the limits too high, you might compete with other things running. And if you set low limits, that might be fine for a lot of applications. But if you run your .NET and you want to try to cheat your whole application on a 100 milli-CPU, that's going to take a while. So your startup time is going to be really crap. So optimizing for throughput and memory usage, I'm not going to go into detail on that. I'm just saying garbage in, garbage out. If you write crappy code, runtime can't fix it. However, some code looks interesting, but it's actually faster. But in any case, profiling, benchmarks. Like I can't repeat myself enough on that. Also, there's some new APIs, new framework APIs, span-based API for everything that's like parsing, working with strings and other formats. Also value task, if you're doing things that are mostly non-async, might improve things down the line. And if you really want to get into the nitty-gritty details, you can also use hardware acceleration, like single instruction, multiple data. There's some managed APIs on top of that, like vector of t. I'm going to actually show you later a sample that really makes use of some hardware calls directly, but maybe don't do that to begin with. So what I really want to focus is like, what other things can I do? I think the obvious one is always stay on the latest .NET. Like every version of .NET is just so much better than the last version. I think .NET 8 is going to be probably the most amazing one in the last 2 or 3 years. So I'm very excited for that. But of course, you benefit for all the improvements that are actually made directly in the BCL, directly in the libraries. So they introduced span, they introduced hardware intrinsics, and then a lot of the string APIs or any other APIs that you use were rewritten on top of that, and they're just faster out of the box. You just need to update. Also, you get a lot of new code generation features. Like if you use JSON serialization, there's a lot of reflection on startup. If you use the source generator, you can actually get rid of that reflection on startup or reflection on first serialization. Also now in .NET 8, there's going to be a configuration binder generator. So you have this scenario where you have like your app settings JSON is loaded into the options framework, and then you say, hey, I have this type configuration object. Please set that up based on that configuration section. Like that's a lot of reflection to do on startup. There's now a source generator to do that. So that's gonna get rid of that reflection during startup. And of course, there's runtime improvements every release. Since .NET 3, we actually had tiered compilation. I'm gonna talk about that in a bit. Also, profile guided optimization, something you will get out of the box with .NET 8, but it's already been there, and I'll show you how to use it already. Some other runtime settings exist. You might not need to touch these anymore. Since .NET over the last years, on every release, they improved working in containers. So there were some GC settings you could play with to maybe nudge that in a better direction, but that's no longer necessary. But if you want, you can adjust your threading settings if you have an application that schedules a lot of work items that are mostly blocking. Maybe you want to change some of the defaults or your code. But I think what's something really interesting, because I was talking about JITting a lot of time, you can actually pre-JIT a lot of the code that you will be running. So it doesn't have to be done on application startup. This has been in .NET Framework for a while. Like even in the .NET Framework, years ago. It was called Native Image Generation Engine. Now there's a new format. It's called the ready-to-run format. So you can say, I'm going to run on Linux, 64-bit. Please prepare the application for the target architecture, generate all the native assembly code, and put it into the DLL. So I ship my application, and if it runs on Linux in 64-bit, it will just use the pre-generated code. The application is still going to be portable, so if I run it on Windows, it will still work. It will just reject the code because you're shipping the IL, the intermediate language, and the pre-generated code in one assembly. So that's actually quite easy to turn on if you publish for a specific runtime or the one you're currently building on in .NET 7 and 8. Just say, publish ready to run true, and it does that for you. Just one little setting. There's some other things you can play around, especially if you're shipping self-contained applications to Linux. You can also say, hey, those are a lot of the DLLs that are in the same directories. If you want to do inlining and other optimizations, just do it. Because you say, I'm going to distribute these like as a whole all at the same time. I'm not going to pull them apart or replace them because that would break it. So there's also an option to do that using publish ready to run composite. So cross-assembly optimization, it does take quite a lot longer to compile because it does a lot of optimizations, and it increases the binary size. But also publish ready to run already does it because then you're shipping your code plus the already jitted code. So application is going to be larger, that's the trade-off, but the startup time is going to improve. And speaking of jitting, another feature in .NET that's been there for years, tiered compilation. So that's also a startup time improvement. So the JIT is going to start up and just generate very, very naive code. So it doesn't run a lot of the optimizations that it can do. It will just make sure that your application will run. This is perfect for some console applications where you just want to like type .NET something help. Like it's just jitted very quickly, it runs, and that's it. But if you then run for a bit, so like in server applications or applications that do some work, this code, this tier 0 code, actually has some instrumentations in it. So it does some call counting behind the scenes, and it tries to figure out like what are the hot paths. And then the JIT realizes, yeah, I mean, this function is called quite a lot. I should maybe look into that. And then it generates tier 1 code for these code paths and does more optimization. So it spends more CPU to optimize the code that you actually run, and maybe not the like wiring up and startup code that maybe just runs once during application startup. And that's on by default since .NET 3. You can still tweak it a bit, you can enable, disable it. Also, it tries to look into methods that have loops, because loops are very inefficient. So it says, okay, it has a loop, I should maybe spend more time with that. However, in .NET 6 and later, they actually improved on that. And that goes into a concept that's called profile-guided optimization. The idea is you deploy an application and then you measure how it actually runs. And this measuring means which code blocks are executed. Like if I have an if, what is the likely execution path? If I have a method that gets passed only interfaces, what are the actual types that come into that method? And based on that, I can then optimize the generated code for what I actually need in production. And that can be really a lot quicker. And this has been done for decades, for example, for C++. And the way you would do this is static PGO, which means you do it while you build your application once, and then it's done. So really, you collect the traces when running the application, however you're going to do that. Then based on these traces, you would generate the performance data, like really calculate the statistics per branch, all these things. And then you would recompile your application with that PGO information. For example, that's how Windows is built. And I think also Visual Studio is optimized this way, apart from the things that you do. And you know, this is perfect for like being ready for the first request, for the first startup. It's just going to be there when you run. And it's also very good to combine with other ahead of time compilation techniques. So if you're doing like publish ready to run, which is done by this cross-gen do tool, or if you look into native AOT, this is the thing you might want to be doing. However, like it's really hard to obtain these traces. Like you need to do it in production, you need to attach, you need to capture logs, and then you need to keep it in sync with the actual application. And now if you really deploy multiple times a day, like how are you going to do that? Like that's really, really difficult to do. And now that's the benefit of having an actual managed runtime and a jitter, is you can do it actually dynamically. So what .NET can do is it can make use of the tiered compilation. So I mentioned tier 0 already has some call counting in it, but they have added additional probes to see, like, do these collections, like what code gets executed, what types, what actual concrete types are getting passed into methods. And then when this tier 1 rejitting happens, like it already does these optimizations using that PGO data. So again, your code might not be fast to begin with. There is a small overhead because there are like additional instrumentation calls like put into your code. However, like you're working with the data that the application runs with, like there's no need to go back and forth, and you can just turn it on. It's gonna be on by default in .NET 8, but you can still turn it on for .NET 6 and 7. So if you're running an application in .NET 7, you can go home today, set this in your project file, and according to the analysis that the .NET team has done, your application should be somewhere in the like 10 to 15% faster. Like if there's one thing you're going to take away from this talk, this, and update the .NET 8 when it's out. And I actually want to show you how to do that and implications. So I have prepared a small sample application. It's really just looping a couple times and starts a workload. And the idea is I have an I factory that creates I things that you can give treats until it feels happy. And there's only two implementations. There's the factory and the thing. However, the methods, my workload, is being passed an I factory, and then always also only calls the interface method on like I thing. Now, if I run that, again, not a benchmark, it's just an application. You will see it takes quite a lot of time, and that's because I've made a grave mistake. I've tried to look at performance data in debug mode. So let's do that in release. Yeah, that's about what I was expecting. So that is actually a .NET 7 application. Now I could add this one flag, but I'm already just gonna change this to .NET 8. Run it again. And observe, it should be a little bit faster. Yeah. So you can see already the first iteration was better. So like apparently something in .NET 8 is already better than in .NET 7. That's even if you turn off that dynamic PGO, it still stays around like 240 milliseconds. And then you see the dynamic PGO kicking in. Because what it does behind the scene is it realizes, these factory call that is passed in, it would try to do optimizations like if factory is factory concrete factory, then it would just call concrete factory dot create thing, and then it does the direct method call instead of doing the virtual lookup for the interface method. That's called guarded devirtualization. And that would be the code that the jitter emits without you having to write it, because you don't know what's get passed into your interface call. And actually, how much of our code is having interfaces and then really only running with one implementation? Like, I think we're all doing that. So that's very helpful to do. Now, if I was really trying to optimize it for first-time startup, I would really try and make this go away. And speaking of the optimization, I can already do something like publish ready to run and so on. But let's just go into our .NET 8 folder. And now let's try to do a static PGO, because that also works in .NET. And I can enable some of these tracing features. So I'm going to tell it, hey, I'm interested in things that are documented, put it into a trace file. So if I run the optimization demo, okay, I got a net trace file. I'm just going to move this up a bit. And there is a tool that the .NET Runtime team built called .NET PGO. You need to actually install that from a NuGet feed of the .NET team, but it's a global tool. And it can help me with these trace files. Now I can do .NET PGO. Perfect. Create MIBC. So I can use this trace file and create an MIBC file. So IBC is like instrumented block count. And apparently the .NET team made their own format. And when they were asked, like they were, what should we call it? IBC? That's at least what the runtime team told me. So I don't think they documented what it stands for. So I have this optimization data file. I can actually look into what is in there. It's in .NET PGO dump. Let's have a look at that JSON file. So you see edge count, so it counts like things that go into it, but here we see a histogram. Now this is our workload method, and here it counts like what are the actual types that get passed into it. And that's our concrete implementation type for the interface that we pass in. And it's only one, but it records like the top things that go in. And then I can also prepare the jitter with that data. So the way to do this is I can tell it, publish ready to run, use that PGO file. And now when I do a .NET publish, no self-contained, ready to run through. So I can see it's fast to begin with, but then there's something weird in there. Because at some point, it figures out, oh, there's a hot code path, maybe I should reject that. Then it somehow forgets that I already have like PGO data in there. However, it then figures out, okay, it should recompile it again using PGO data, and then it gets better. There is a fix for this, and it behaves now differently in newer .NET 8 previews than before. There's two ways to fix that. First of all, I can actually embed that PGO data into the assembly. So I can publish ready to run. CrossGen 2 is the tool. I can pass it extra data and say, please embed the PGO data. And then I need to do something bad. I need to disable tiered PGO. That's currently the way to do this. And it has to be both, because tiered compilation will still kick in. It would still try to recompile the application, but then instead using the PGO data that it tried to collect at runtime, which won't be there because my pre-generated code does not have these probes, then the tiered compilation will reuse the performance data that I embedded into the assembly. So I've published that again. And if I'm not mistaken, we should now be fast on the first request, like on the first iteration, and then throughout the entire lifetime of the application. So something we can do. However, if you're not wanting to do all of these, just enable dynamic PGO in .NET 7 and then update to .NET 8 when it's out. That's really what you should take away. But I think that's a really, really cool thing that the .NET Runtime team is doing. And of course, I like to play with stuff that's cool. Okay, let's go to application size. There is a feature in .NET that's called trimming. There've been a couple of iterations of that. The latest one using a trimmer that actually comes from Mono, from the Mono team. The idea is to reduce the size of self-contained apps. So you ship your application together with the runtime, and then you really try to, as aggressively as possible, remove all the things that are not needed. So it removes all the assemblies that are not used, but also the code paths that are not used. So you will lose any types that are not accessed, any method that is not accessed, every property that is not accessed. It's basically tree shaking. So it's based on some roots that you can describe, some root assemblies. You can also pass it some XML to tell it what to keep. Then it will shake your application. Everything that's not connected to the roots is going to go away. And now all assemblies are trimmed by default. There, again, I mentioned there have been some iterations of that where you could control some, you can opt in some, opt out some. Now everything is trimmed by default and quite aggressively. There are some limitations to that. And of course, dynamic code can be problematic. Like if it went away, you're no longer going to be able to use reflection to find it or to call members of it. COM is also a bit difficult. There are new ways of doing COM in .NET using COM wrappers, but not everything has been fully converted to use that. For example, WinForms uses COM quite extensively, and it hasn't been fully converted to COM wrappers in .NET 7. I think there's some more in .NET 8. However, I don't think they're promising that .NET 8 it will work for all the scenarios that use streaming. For example, native AOT. And of course, WPF, I think they looked into it and said, yeah, it's like WPF is actually a reflection with a user interface. So that's going to be hard to do. And if you're writing your own code, maybe be careful if you're using serializers. They mostly use reflection, for example, to invoke setters of things. Like if all the constructors and your setters of your data objects are gone, you're going to have a hard time. So use the source generation helpers, like for system.json instead, to make sure your applications are compatible with trimming. And of course, dynamic assembly loading, if you have plugins, it's going to be a hard time. But what do you do to make sure your application might behave better with trimming is there's no attributes. And if you read through like .NET release notes, you will see, oh, in .NET so-and-so, more and more assemblies like these things have been properly attributed to support trimming. That's basically what these attributes are for. So whenever you have like a type, like system.type, you can tell it, hey, I'm going to dynamically access some members, for example, the constructor, properties, instance, or just all, that you can say, yeah, keep it. If you see like type of something in that place, like keep all the members. Also, if you have methods that really do not work with trimming, you can say, hey, this requires unreferenced code. Just if someone uses that in a trimming scenario, emit a warning. And you can suppress that warning as well. So also you can say, hey, this method, it will dynamically use this type. So keep that other type around. And of course, all these messages that are then generated, warnings, errors, you can suppress them. The difference between suppress message and unconditional suppress message is like unconditional, it will end up in the assembly, so that the linker that processes the assembly can actually see it. So if you have some libraries, component internal, or you ship NuGet packages, you can already enable these warnings, even if you're not using trimming. The property you can set in the project file, annotate the code, and of course, documentation. But I want to actually show that to you. So let's go here. So I prepared the thing I told was difficult, like plugins. Plugins for me have a name and they can do something. Like plugin A has plugin A and it just writes a message. B and C do the same. And then I have a plugin utility that knows how to create a plugin. Like maybe this is something where you would have some other logic, and it can find all plugin names. What it does, it tries to find types that implement I plugin, instantiate them, and call the name property. And then I have my application that just uses this, iterates over it, and just tells me which plugins exist. So I have ABC. Now what happens if I actually, let's do it single file. And enable trimming. Publish trimmed true. Like I already get some warnings. I see my application is 12 megabytes in size. That's quite a lot smaller than the full runtime. That would be like in the 70s to 100 megabytes, depending on which runtime you use. But if I run my sample application, there are no plugins. They're all gone. And how do I keep plugins? Well, for example, if let's say I did something with plugin B, so it knows it needs to keep the type around. If I publish again, it would keep the type. But now there's an exception because there is no constructor left. Because I didn't explicitly say new plugin B, so the constructor is gone. And how do I fix that? So one of them would be annotating. So I'm using this create plugin method here. And what I can do is I can say, hey, if someone calls create plugin, then on that type they pass in, just keep everything. Because I'm going to dynamically access everything. So let's publish again. This might take a while. Hey, and now plugin B survived completely. But let's say I do not want to do that. There are other ways to get around it. For example, I can declare what types I need. I can also get rid of these messages. Let's say, hey, if someone calls that method, they should know what they're doing, or I'm working around things that help the user do the right thing and not end up with an error. So two ways of specifying the same thing, direct reference or referencing by string. And then the linker should know to keep plugins A and B, and they're still working. Something else I could do is declare static fields, annotate them. So everything that has type and is annotated, it will keep that around. But maybe writing static constructors that keep plugin around, weird thing to do. So another thing I can do is using trimmer XML definitions. So there's an XML syntax that it can pass to the trimmer to say, keep these things. So I can specify the types. I could even go down and specify individual methods, properties, even fields to keep, and it would try to remove the other ones if they're not used in some other way. So I can use this XML file as well, and in my application, I can then say, hey, trimmer root assembly, include an assembly, or use that descriptor. So this descriptor is now telling to keep plugins ABC. Let's just make it A and C to just see that there's a difference. Okay. Okay, A and C are now there. And that's a useful thing to do if you have an application and say, hey, I need these things. But if you're authoring your library, like telling end users what to put into their XML, weird. So you can do something different. I can actually move this to the library. Let's change it to B and C. And in my library, I can actually embed this file as a resource with a specific name, IL-link. That's the linker that's used to trim away everything that's not needed. So I'm embedding this file. And then the linker should see these things. So if you're writing libraries, like company internal libraries, NuGet packages, those are easy ways to make sure that every user has the right or keeps the right things around if you cannot remove all the reflection that you need to use. So let's run it again. Perfect, B and C are still there. Now, that is actually a prerequisite for a very, very cool feature that the .NET team has been working on for a long time. There have been experiments for it, there have been iterations on it. If you use UWP, you might actually already had to have dealt with some of these implications, but native AOT, native ahead of time compilation. Like I really want to get rid of all the JIT forever and reduce the application file size to the absolute minimum. So my application will be fully ahead of time compiled. Funnily enough, that's exactly also what you would need on iOS, where you cannot do any JIT compilation. Like you need to sign the executable that is run. If you have these scenarios, AOT comes really in handy. So there's no JIT at runtime. You'll get the smallest binary size possible. It's already been supported for console applications in .NET 7. And then in .NET 8, now they support minimal APIs. And of course, the prerequisite, and that's why I showed it to you, all applications and libraries, like everything needs to be trimmable. Like that is the prerequisite to use native AOT. Also, when you're compiling, you need to have like a native compilation toolchain. So for example, on Windows, this means also in Visual Studio, enabling like C++ development for Windows. The .NET team gave us a nice graph of how things looked, I think, March, April, like around that time frame. So you can see application size, I think that's now even better. I think that's now even below 5 megabytes. So that graph is already out of date. And it uses less memory, because again, the JIT needs to do less work. And the startup time is just phenomenal. Like, it's ready to run. It's a binary. However, what's missing here? Throughput. Because it's still the same, it's still .NET. Like, it might be ahead of time compiled, but it's still the same throughput. It uses the same compilation mechanisms as the JIT, the same optimizations. It just generates a binary out of the native code. Again, some limitations, unit trimming, dynamic like runtime generation, reflection emit, that just doesn't work. So if you have, for example, lambdas or expression and you want to run expressions, like those are always going to be interpreted. Dynamic loading of assemblies just doesn't work because there's nothing to load an assembly and JIT it. C++ CLI, that's on you. Interop, again, like new versions might work, otherwise you're going to have a hard time. And of course, it's now being a single file deployment. So all the things that already apply to single file, self-contained publish, single file deployments apply. Like assembly get file will just throw an exception. Of course, if you want to recompile your application, you need to include the new runtime. So whenever there's a runtime patch, you need to rebuild your applications. Nowadays with DevOps, I think that shouldn't be a problem. And what I'm really excited about in .NET 8 is the support for minimal web APIs. There's some exceptions to that. For example, everything that uses MVC or views, SignalR doesn't work. Authentication, I think they want to get at least draw tokens working. So the minimum for the application framework. So session still doesn't work for other reasons. Database access. So they worked with NPG SQL to get at least the Postgres connection working with AOT scenarios. Also, SQLite works. However, I think the Microsoft SQL connection still needs some work. And on top of that, again, like session would support that. So like there's dependencies. But if you're writing, for example, a function application, a very simple API, and maybe you have your authentication before that, that just should work just fine. So also refer to the documentation. And I want to show you a bit of that. And let's maybe start with a different application than an API. And I prepared a demo with a small terminal application that actually processes some data and calculates a result. So it is a cost optimization demo, so it tries to find like the cheapest assignments of some tasks to assign. But that's not really important. The important thing is there is data, like it generates a CSV file or it reuses it, does some calculation on it, and tells me how long it took. So let's publish this, and let's say I published in release mode, single file. Let's do that. Perfect, and you see there's now a 68 megabyte file in here that just does some calculation. Like it works, it's fine, but it's really huge. So I showed you, publish trimmed. Nope. Yeah, 12 megabytes or 13. So much, much, much better. And does it still work? It works, like 6 seconds. So now I can replace most of that. Say I wanna, like it's a console application, it's a small tool. I want this to be really small. I want it to ship it to a specific runtime. So I can do publish AOT true. This means it will run the linker to remove everything that's not needed. And now it says generating native code. Now it's there. Let's have a look at it. 3 megabytes. However, and I don't think I'll run that. It's now going to take, I think, 40 seconds. Why does it now take 40 seconds? Well, something about that algorithm is I tinkered with this quite a bit because I needed it to actually for a data science applications, we were tracking applications, and it's also a very good global nearest neighbor algorithm. However, it has cubic complexity, so not very, very fast, but I tinkered with it and made sure that it uses hardware intrinsic to be as fast as possible. However, I did that manually because it was fun, which means that there is code in there that looks like this. If AVX2 is supported, so if I'm running on a CPU that has that CPU feature, then it runs some weird fixed float thingy, AVX, load vector, min, max, permutate, something, remainders, minimum, just to find a minimum. Like, the naive version of this code is just 2 for loops and an if. But there's a fast version. However, AOT tries to be like as conservative as possible in like what is the target supported architecture. Like it should run on a computer that doesn't have AVX2. That means when it compiles this in basically the component that would do the JIT, like this would be false, and it would just remove the code block and run the naive code, which is quite slow for all of these methods that are in there. I can fix that, however, because I can tell this program, ILC, the IL compiler, to say, hey, instruction set, like assume the features of a Skylake processor or higher. So like these 2017 Intel chips or higher, even AMD now supports these instruction sets. So I should be fine. And it's also something to consider where you ship things to. So it's also why Azure and other clouds document like what processes do they actually use. So if you really want to optimize it, you can do that using the instruction set, because like .NET supports all the machines as well. Okay, perfect. Now it works. And it's still 3 megabytes. So that's amazing. Now, in .NET 8, so where are we? Yeah. Well, then I'm just going to show you a different way. I can do .NET New, Web API AOT. There's a new sample. And that sample actually, I'm just going to check. Nope. Okay. So in that sample, it's basically their to-do sample, which just returns like a static list of to-dos. And you can see it's a web application. It says web application create Slim Builder. However, if I assume this wasn't there, which probably will not be there in your application when you start, like it should still work. Like if I do .NET run, perfect, it runs. Let's send the HTTP request. Type not supported. What did I do? Create Slim Builder. That's when you don't start with your own samples. Let's add that in. So then let's leave it like that. What this actually does is, again, system text JSON. Normally it would use reflection to analyze the types that you have, like the to-do object, and see, okay, you have these, okay, now I know what's happening, because it uses result.okay and not the actual type, so it can't do this introspection. However, it would try to do reflection to generate all the metadata. However, we cannot do reflection in AOT. So that's why we have one of these source generators that will behind the scenes, generate all the accesses, all the setter methods, all the necessary type information. And the way to do this is you create a class, partial class, that inherits from JSON serialization context. Then you add a special attribute of like, hey, I want to have this context know about all of these types that are passed in here, all of these attributes. So it should know about arrays of to-do. So that will generate code to serialize and deserialize arrays of to-do, also the to-do class, and also any types that might be reflected. So I can actually have a look at that. Can you either find the code? It will show up in Visual Studio Azure. Yeah, okay, no, that's not it. Whatever. The idea is you use generator, you pass it along, you tell it, hey, if you need to resolve type infos, use this context, and this will work in AOT scenarios. So now if I publish that, so .NET Publish in .NET 8, it does a release by default. If you're using features that need a runtime, it will use the current runtime, like Windows 64-bit in my case. And in this case of the template, publish AOT is already in the project file itself. So we should now get a release, publish. We got an API app. Okay, it's 9 megabytes in this case. It runs. Now let's run the HTTP request against it. By the way, you know this feature, right? You can just use .http files in Visual Studio Code. 5,000. Okay, that works. That works. So the JSON serialization works without reflection. So that's about .NET 8. Since I have a couple minutes left, I also want to show you another cool feature of native AOT. It's probably I'm excited about it. Let's see if some of you appreciate. I also have a library here. Nope. So I have a library here, a .NET library, .NET logic. Let's say I want to reuse that logic from anywhere. Anywhere means someone might decide to build an application in C, C++, maybe in Objective-C, maybe in Android and would write some C wrappers. Of course, I could use some tools for .NET to deploy to iOS or to Android. But in the past, I had to do it the other way around. I had to implement some logic in C, C++ to really be able to reuse it across all the platforms that I need. I could actually now do this in .NET. And the way to do it is you make sure you have a public static method somewhere. Maybe only use types that you can actually use for marshalling and demarshalling. In my case, I want to deal with C-style strings. So I'm just using pointers. And then there's this magic attribute that says unmanaged callers only, which if I compile this using native AOT, it will create an entry point for other applications. So if you go into my library folder, also notice I'm doing this on Linux just because I'm a little bit more comfortable with C on Linux than on Windows. Now this is now my library, so this is really .NET 8, and it doesn't say executable or anything, so it's a library project. I can still do a .NET publish on it. Let's say publish AOT. Equals true. Yeah, I'm using a preview. Yeah, in this case, I also need to specify runtime. So I'm using Linux 64-bit. generating native code. So let's see, Linux x64 publish, and now we got a .so file. That's a shared library in Linux. If I were to compile on macOS, this would be a .dylib, and on Windows just a DLL. Also, it generated the debug information to a different file. So like on Linux, you would know this strip command, so I don't need to run that. Let's move that to my sample application. So first of all, let's have a look at that. Now that's a 1.5 megabyte library, and that contains all I need, all like the .NET runtime that I need just to do a greeting. And now I can use a C-style application that maybe I would ship this with a header that says, hey, this method exists, but it knows, it just tells it, hey, forward declaration, somewhere there's going to be a greeting method that it can give a character array into, and I will get character arrays out of it. So very basic C# strings. Now let's do a name Copenhagen, call greeting, print a result. I'm just gonna actually rename this library, because like the convention that linkers use is lib something, and I have a compile script here that I'm gonna run that uses the Clang compiler to compile my C code to an output, links against a sample lib, so it looks for that lib something dot something. Also, like Linux has this special, like libraries should be in these paths. Also, when running an application, it would only look at these paths. Like I'm telling both the compiler and then the runtime linker commands, like also look in the same directory that we're currently in. Those are these arguments. Now, I have an application here, sample, and that just started the .NET runtime, executed my .NET method, and that did all the interop necessary between C and .NET. So I think that's pretty cool, because no longer you need to like create a runtime, load a library, find the entry point, do the marshalling. It's just one call. And I think this is really amazing. It also works with static libraries instead of dynamic libraries. Just that when you do that, you also need to bring all the static libraries of like these .NET runtime parts. Like it works, just a little bit more complicated. So just a thing by the side. So, and then for the last takeaways, I showed you a lot of things today. I want to give you some recommendations to take with you. First of all, if you want to publish and you're running on .NET 6 and higher, especially .NET 7, enable dynamic PGO. Like it will be a bit faster, and it's now the default in .NET 8. If you want to optimize for startup, use ready to run. It will increase the startup time a bit, with the trade-off of making your binaries a bit larger. And if you want to optimize for startup and size, you can go full into trimming, especially in Linux, ready to run composite, and of course, doing the self-contained to do the trimming to have like the minimum size possible. So then, for example, when you build a container, you no longer need a container that contains the full runtime. So you can do a lot smaller small applications. So with that, I'd say thank you for being here. I will be available for questions. Also, I'm going to be there for the rest of the conference. Thank you.